So by now you should be pretty excited about this contest. I am too. But I'm just as excited to reveal this mace, which will be a prize at the contest. It's a little over 12 pounds and 23 inches long. The mace, that is. I always try to contribute to the grip competitions that I attend by bringing some unique grip tool, but this time I wanted to do something different. Although you could train with this, I designed this to be a trophy, something that you could put in your home or your office and be proud of. So I don't want things to get weird, but GripSport has been very rewarding to me and I've made a lot of great friends along the way. So this is one of the ways that I can give back, if you will. Now the rest of this video is going to detail me building it. I won't show you everything, but you'll get to see a lot of pictures, video, and some time-lapse montages. So if you're into that, stick around. So I don't want to bore you too much, but I thought I'd at least show you the process I went through to figure out the dimensions. And I apologize in advance for these very poor two-dimensional representations of 3D objects, but hey, this is what I'm working with. So the idea is simple enough. It's a 4x4x6 rectangular prism, similar to the hammers that I made for Nate's comp in February of 2018. But the difference is, this hammer has a pyramid on each of its faces. So I know what the perimeter of each of these pyramids is going to be based on the dimensions that I've already stated, 4x6 and 4x4. And I also know what the rise of each of the pyramids is going to be. For the 4x6 sides, it's 1.5 inches, and for the 4x4s, it's 1 inch. But I needed to calculate the height of each of those triangular faces. Now the reason I want to know the height of each of these triangles is to simplify things for me, so I'm not measuring a bunch of angles. I can just measure dimensions. So I broke each one of those triangles into right triangles and used the Pythagorean theorem. So now that I've probably insulted your intelligence, let's get into the build. I'm making this out of 3/16 cold rolled steel, mostly because I don't want to clean hot rolled mill scale. Now there are a total of 24 triangles that I'm going to have to cut, but there are only 3 that are actually different from each other. So I've made templates for each one. Now, just like most things in life, there's half a dozen ways that you could do this right. Some are just better than others. Now this is the most convenient method for me. I'm using the templates to scribe lines and then just using a cutoff wheel to cut them out. Now I'm not using anything special here, I'm just using a 6-inch grinder with a Metabo slicer. I like to use a diamond blade most of the time, especially for stainless, but in this case I'm just using the Metabo, and it's making a very clean cut with very little cleanup to prep these for welding. And each piece that I cut, I checked against the template. I'd love to say I cut them all out perfectly the first time, but I didn't. I even had one that I had to cut it 3 times and it was still too short. So here are all 24 of the triangles that will make up this thing. So now all that's left to do is everything else that goes into making it. So once again, I wanted to simplify things for myself so that I'm not measuring a bunch of angles. So I made a series of jigs to hold the parts for me so that I can weld it and work with it. Now ideally I'd like for each of the pyramids to be perfect. I know they're not going to be, but I'd like it to be that way. I'd at least like them to be pretty accurate, especially piece to piece, because that's going to help me put it all together. So I've got these pieces of aluminum welded to a 90-degree angle to help me hold 90 degrees in each of the corners. And I've got this little fixture here to hold the rise for the pyramid. Now it's a bolt so that I can play with that height a little bit. Now going into this, I imagined that as long as the base of the pyramid is a rectangle, I can deal with that if the dimensions of each of those rectangles are slightly different, or at least no more than a 1/16 of an inch off. Whereas if I don't have 90 degrees in each of those corners, it's going to be a lot harder to deal with when I start putting these all together. At least that's what I think anyway. So once each of the parts is put into the fixture, I'm just using bridge tacks to hold everything together, mostly to minimize my heat input. One of the trade-offs with working with cold rolled steel is that it has tension sort of pent up in it, if you will. So it tends to pull in the direction that you're welding. Not always, but it normally does. Now if I had to do this over again, I would probably use more tacks, but this worked for what I was doing. And once again, I was trying to minimize my heat input. Now the 4x4 pyramids have a smaller rise than the 4x6s do, so I had to adjust the height on that bolt. I also scribed some lines on my table just as a visual guide or reference. So I have to admit that when I got this far into the project, things started to get really exciting because it was starting to take shape. Although I had drawn this out on paper many times, I really wasn't sure what it was going to look like when it was put together. And once again, I'm just using some bridge tacks to hold everything together. Because I know in my heart, deep down inside, that I'm probably going to have to cut a few of these loose to make this thing work. To fixture the rest of the parts, I'm just using a piece of aluminum square tubing to hold that 90-degree in those corners. And that worked pretty well. In fact, it worked really well. The only trouble I had was making the last two edges meet up. It wasn't that far off and it was pretty easy to fix. And honestly, I'm pretty surprised that that was the worst problem that I encountered in this project. Now you probably saw me use some filler metal to help me hold a gap when I'm putting these ends on. That does two things. Number one, it helps me get full penetration. Number two, it gives me some wiggle room to move the parts around. So now that it's all tacked up, it's time to clean it up and get it ready for welding. So when I was designing this in my head, I imagined that all of these weld joints would be kind of like outside corner joints. But instead, they ended up being like fillet welds with a really bad fit up. And I say that because the weld joints butted together with only about a 3/16 of an inch opening, so there wasn't a lot of room to manipulate the electrode around. And my main priority was that I didn't chew up those edges, because we're going to come back and cap these welds with silicon bronze. So I mitigated that by using 0.45 diameter filler metal and just holding a really tight arc. I've got the tungsten as far down into that joint as I can get it without contaminating it. And that really seemed to work. So I'm trying to just fill to flush or slightly below flush because, like I said, we're going to cap this with some silicon bronze, and I don't want to chew those edges up. I want to have a nice clean edge to run that silicon bronze on. Once it's all welded out, it's time to put the handle on. I'm using a piece of 1.5" Schedule 40 pipe. 1.5" is really popular with the kids right now, and I also just happen to have a cutoff laying around. Now I'm marking the pipe where it's going to sit on the corners of that pyramid, because I'm going to come back and file the inside so that it sits nice and flush. And once I was pretty sure that I had it centered up right where it should be, I went ahead and put a couple tack welds on it and checked it for runout, made sure it was nice and centered. So on the end of the handle, I'm going to attach this 3-inch hollow steel ball, but it needs to be cleaned up. So I'm going to weld this bolt to it so that I can chuck it up in my drill. Now you're probably asking why. Well, keep your shirt on. You're about to find out. Now this method has been affectionately referred to as the redneck lathe, and it's not for everybody, but it's the best method that I have available to me right now without a lathe or any special tooling. Now like I said, it's not the best method out there. And if you have the proper tools, then I recommend you use them. And that is pretty much what I was going for. So now it's time to attach that to the end of the handle. If you'll notice at the end of the handle, I've got a hole drilled in it, and that's to let the heat out so that we don't blow the weld open. Now I think I'm using 309 filler metal here. That's normally used to join mild steel to stainless steel, but it does work in this application and it flows really well. So the final step in all this was capping each of those weld joints with silicon bronze. Silicon bronze is a brazing wire. There's a lot of applications for it, but in this case it's purely cosmetic because it has a gold finish. Now like I said, silicon bronze is a brazing wire, and it melts at roughly half the temperature that mild steel melts at. So it's really easy for the heat to get out of hand and to discolor things too much. So to mitigate that, I'm using the pulsar in my welder. I think I'm at 1.5 pulses per second, about 35% on time, and about 50% background. Now, I won't even attempt to fool you here. Those are not settings that I came up with. Jody from Welding Tips and Tricks uses settings similar to that, and they work really well. It helped me keep the heat in control, and it also made sure that I had a nice consistent bead profile since the cosmetics are so important. So this was one of those watershed moments in the project where things had finally came together, and I just couldn't believe how it turned out. Now I debated on leaving those blue bluish heat lines there, but I ultimately decided to go ahead and clean those off to kind of polish the silicon bronze. And in short, I'm glad that I did. I used a wire cup brush to just clean it up, and an unexpected thing happened. Some of the bronze from the silicon bronze embedded itself in the steel. I was hoping to have a really sharp contrast between the silver and the steel and the gold, but instead I got kind of an oil-rubbed bronze look, if you will. So all that's left to do now is wrap the handle in something. Now I debated on tennis racket tape, but ultimately decided on paracord. And if you'll notice, I wrapped it to exactly 7.5 inches because I ran out of paracord. Well, I think that pretty much wraps it up. It was a really fun project, and if I had to do it over again, I know there's some things I would do differently, but I definitely learned a lot. I certainly enjoyed it. And if you stuck around for this long, I hope you enjoyed it too. Thanks for watching. And don't forget to tune in next time when I'll be